In this video, we're going to look at a fairly common factoring method, which is always typically the factoring method you should start with first, but that is factoring monomial expressions, or mono meaning one, but factoring out a greatest common expression or factor from each of the terms in an expression. Okay, so we say sometimes all the terms in an expression share common factors. In these cases, what we can do is we can factor out the common factors from each. So you'll notice that I make a little note here. I say this is like reverse distribution, okay? And so in other words, when we do a factoring method, we're doing something that is the opposite of distribution, which is multiplication. We're doing something that is instead division. So what I want to do is I actually just want to jump right into these and talk about what it is that we're discussing here. But basically, if we had 5x squared minus 20, let's go ahead and take a look at this. If I were to rewrite this, I could rewrite this as 5 times x times x. If I were to completely factor my 5x squared, we say minus 20, which in reality, minus 20, that's like, what, 4 times 5, which is 2 times 2 times 5. And what I want to notice here is that when I subtract these two numbers, okay, which is 5x squared minus 20, that they both have a 5 in common as a common factor, okay? So what we're going to do is we're actually going to list that 5 out front. And the thing is, when we take a 5 out, this is the opposite of distributing, which would send a 5 through. We are actually taking the 5 out, which brings this out. So everything that's left on the inside of this expression here is going to be minus a 5, not minus a 5, but it is going to be less that 5. And maybe I shouldn't even use the word less. It is going to not have that 5 there as a factor anymore. So we're dividing out the numbers that we put out front here. So for instance, if I had 5x squared divided by 5, well, 5 divided by 5 is 1. And I have x squared. I didn't take out any of the x's, so I'm going to leave the x squared. And then I say, now, negative 20 divided by a positive 5. A negative divided by a positive is a negative. You notice I already put the negative here. And then we say 20 divided by 5 is 4. So I get this expression right here, 5x squared minus 4. So now our job is going to be to factor. And the thing that's important to keep in mind here is this: factor completely. Okay, when we talk about factor completely, we're really referencing the fact that sometimes once you factor something, it could keep being broken down. So for instance, even with 20, we said it's 4 times 5. But when I say factor completely, that means we also need to go find these other remaining two factors here. Okay, so what we need to do is recognize that right here we have a difference of squares. X squared minus 4 is a difference of two squares. So when we factor this all out, then we say this is going to be the same thing as if I leave that 5 out front and I get conjugate pairs here. We say x plus 2, x minus 2, because x squared would give me x squared and 2 squared would give me my 4. That's going to give me a difference of squares. So we say here's my completely factored expression. So the idea in this worksheet is going to be that when we factor something out of every term, we'll divide all the remaining stuff by what we factored out of each. Okay, so looking through this expression on letter B, we say, are there any greatest common factors between 6p squared, 15p, and 9? And I notice that 6, 15, and 9 all share a common factor of 3. And I notice that not everybody has p's here. This one has 2 p's, this one has 1, this one has none. So they cannot all give a p in terms of a common factor. So when we rewrite this, we're going to divide everything that's left on the inside of this expression by the thing we put out front. So 6 divided by 3 is 2. We still have 2 p's. And we say, well, 15 divided by 3 is 5. We still have a p. And then we say positive 9 divided by positive 3 is 3. So we say here is our factored expression. As a matter of fact, this expression right here we could keep factoring. So we could say, all right, well, what would it factor into? Well, the thing here is this. We say 2p squared plus 5p plus 3. To factor a trinomial where the a value is not 1, we said we would multiply the first and last term and get some value here. We say 6. And we say, what are the factors of 6? 1, 2, 3, and 6. So we say, can we think of two factors of 6 that multiply out to be a 6 that add up to be this middle term here? And I noticed that a positive 2 and a positive 3 would. Okay, so we could say that this is the same thing as 2p squared plus 2p plus 3p plus 3, where all we did was we ripped this middle 5p into 2p and 3p. And then we'll solve this by grouping, or we'll factor by grouping. So I'm going to go ahead and group this here. Say keep this plus right there. But I noticed that in terms of GCF, what do these have in common? I noticed that they both have a 2 and a p in common. And we say, well, if I took 2 divided by 2, I'd get 1. If I took p squared and I took out a p, I'd be left with 1p here. Now if I said plus here, what would I get? 2 divided by 2 here is 1. And then p, if I took that p out front, it no longer has a p. So really this is just 2p times p plus 1. You could see that if we redistribute it here, we get 2p squared plus 2p. So we say plus now. I just carry down this plus right here. We say, what do these two factor or terms have in common? They have a factor of 3 in common. So I'd be left with p plus 1 also. And I notice that all of this plus all of this, they have a common factor of p plus 1. So we're going to take out that p plus 1 out front. And I wind up with this p plus 1 2p plus 3. Okay, so now this is keeping in mind that this would have a p plus 1 and this would have a 2p plus 3, but there's a 3 out front still. So, okay, so this is our final factored expression right here. Moving on to letter C here, we say, okay, well, what do these two terms have in common? Anything that look like they both are even, the coefficients, so we say a 2 can come out of both. I notice that they both have u's. Now this one has 2 and this one has 1, but they can both at most give 1 u. So we say, well, 2 divided by 2 is 1. U squared, if I took one of those u's out front, I'd have 1 u left here. And we say, now, positive 8 divided by a positive 2 is a positive 4. And then u, if I took that u out front, I'm just left with this. So we get left with this. We say 2u times u plus 4. This is our factored expression because I could not factor this any further. Let's move over here. We say that all of these are even. So let's go ahead and try to factor something out here. We say, well, 2. If I divide everything by 2, I'm going to be left with 2x squared plus a single x minus 2. And we say, well, can I keep factoring this? And that's something that we would need to check. We'd say, okay, can I come up with two factors of 2 times negative 2, so two factors of negative 4 that add up to be a positive 1 here in the middle? And I can't think of any in this situation. So we say this is actually as factors as we can go. Looking down up here, again, 14x squared plus 2x minus 12. The first thing we do is look for common factors. And so we say they all have 2 in common. So we'd say, well, this would be 7x squared plus x minus 6. Okay, and actually, let's check this one out and see if we can factor it. So we'd say over here on scratch paper, we say 7x squared plus x minus 6. Let's take our 7 times negative 6 get negative 42. We say, what are the factors of 42? We say 1 and 42. We've got those there. And we say 2 and 21. 2 and 21. Okay, how about 6 and 7? These are the ones that I can think of here. So are there two factors of a negative 42, which means they have opposite signs that add up to be a positive 1 in the middle? And I suppose we could do like a positive 7 and a negative 6. So we'd say if that's the case, then this would be rewritten as 7x squared plus 7x minus 6x minus 6, where we split this up and we're going to group these now. So group these. What's the GCF of the first two terms? We say 7x, and this would be left with x plus 1. Plus, just carry this plus down that I had to put in there. We say, let's take a negative 1 out of these second two terms here. We say, well, taking out a negative 1, actually take out a negative 6. They both have a 6 in common. So we'd say this would become x plus 1, really. And I notice that now both of these terms have that in common. So we're going to take that out front. So we get left with this x plus 1, 7x minus 6. Now, that is what this broke down into. And we still have a 2 out in front of this. So we get 2. And we were left with x plus 1, 7x minus 6. Let me rewrite that, 6 minus 6. But this would be our factored expression. Okay, so a few more here. Let's take a look at this one. We say 3v squared minus 18v. They both have a 3 in common. They both have a v in common. And if I were to divide out 3v, I'd be left with an individual v. And then a negative 18 divided by positive 3 is a negative 6. And I took this v out front, so it would just be this guy right here. This last one looks like they all have a 3 in common. So let's take 3 out. I would get left with 4x squared plus 1x plus 1. And say, well, I don't know, is this factorable? We could check this out right here. So we say, I don't know, 4x squared plus 1x plus 1. If I multiply my leading coefficient times my constant term, I get 4. I say, what are the factors of 4? So we say 1, 2, and 4. Can I think of two factors of 4 that, are both positive, both negative, but also add up to 1, and I can't think of any. So this would be as factored as we could get it. And then finally, this last expression here, we say 4u squared minus 36. I notice that these are both squares themselves, but the first thing we're supposed to look for is a common factor. So instead of doing a difference of squares right off the bat, let's take out this 4. We say they both have a 4 in common, and I get left with u squared minus 9. And I also notice that this is a difference of squares, so we can factor it into u plus 3, u minus 3, and this would be our completely factored expression.